If you have a pendulum, this is a pendulum, mass m, length L, then you can derive, which I do in class, but I won't bore you with that, you can derive how long it takes for the pendulum to make one complete oscillation. And we call that the period of the pendulum. And I derive in class that that period equals 2 pi times the square root of L over G. You already know what L is. If you don't know what pi is, you might as well leave right now. And G is what we call the gravitational acceleration, which is approximately the same everywhere on Earth, but it is very close in Boston to 9.80 meters per second per second. And you will say, well, that's weird, meters per second per second. What that means is that if you have an object and you drop it from a very large altitude, very high, a few hundred meters high, and I dropped it with 0 speed, after 1 second, it will have a speed of 9.8 meters per second. But after another second, it will add to that 9.8 meters per second, so it's twice that. And after 3 seconds, it's 3 seconds. So now you understand why it is meters per second per second. And so that's the meaning of G. There's something weird about this equation. Something that must go against your intuition. And you shouldn't feel bad because it also goes against my intuition. So we have the pendulum, and suppose I bring the pendulum all the way out here. We call that the amplitude of the pendulum, and we let it swing back and forth. There's a certain period. But now we bring it out only this far. It doesn't have to travel very much at all. Doesn't that make a difference in the period? The equation says no, it doesn't. Because if it did make a difference, there would be in that equation the amplitude, which is not. And I'm going to demonstrate that to you, that it is quite remarkable that indeed that period is independent of amplitude if you don't go to extreme values of the amplitude. There's something else in here which is even more non-intuitive. And that is, doesn't it matter whether the bob, we call this the bob, whether it is 1 kilogram or 500 kilograms? You would think, wow, that must make a difference in the period. But the equation says, sorry, it doesn't. And I'm going to demonstrate that.